We'll continue with our video lecture session for applying over the projects. In the project 1, we'll look how to apply the solutions and visualize the result. And in project 2 also, we'll be applying the same principle over the tower which we have designed, and we'll see the deflections and other stress plot. And in the project 3, we'll look into the disk and how to solve it, which already we have seen. So I'll continue with project 1 and 2. So project 1, if you see, this is all about a beam and how to plot the result and how to visualize. Let us open the exercise file, that is for the project 1 which we use. I'll go to solution. Now I'll be plotting the result. So various methods are there. You go to general post processor, plot result, contour plot, nodal solution. I need to see the y component deflection. This is the deflection which you can see, and this is the minimum, and which you can see through a range of plots. And when you see the stress result primarily, there you will get the validation technique. If you see the stress, that also you can see here. But primarily if you see the deflection plot or the stress plot, which directly gives you the understanding that this problem is safe or not. How can you define this? Until and unless you don't know the allowable limit, yielding limit and ultimate limit, you cannot validate a problem. Whatever the stress maximum you are getting and whatever the deflections you are getting, that is related to strain and your stress failure. So if you know the allowable limit and you know your maximum plot, and when you equate that to your allowable limit, if you have a margin factor, then the model is safe. If that factor is not safe, then you have to redo the design, or maybe the conditions which you have considered in analysis, that you have to change, or literally you have to change both the things. So various cases are there where you have to see this. If you see the second project over the tower, there you can also find the same conditions, and you can visualize that how the deflection is different over different conditions. I am solving the problem and I will be visualizing with the deflection and other plots. Go to general post processor, nodal solution, and I will be seeing the DOF, degree of freedom, and I will see the y direction and x both, because the load is applied on both the direction. When I am seeing the x direction, you can see the maximum compressive load I am getting the -12, and the tensile load I am getting 7.2, where it is shown here, the minimum and maximum. What about the x direction? When you see the x direction, the x component is very minimal, and you are getting other directions here. So when you see the comparative study between the particular direction, and you will be able to judge that what about the axial condition also, axial stress which you have. So you can directly go to the list result, and you can go to directly element solution, and you can directly go to the line element results, where you can see the axial stress data also. Axial stress is 340, 64, and somewhere it is 40, somewhere it is compressive this much. This much axial stress is allowable or not for that particular material, that you have to decide over different links. You can see here 20 links you have, 20 different bars you have for this truss. So over all this bar you have the various stress plot, that is known as SAXL, axial stress. So by comparing this, you can directly understand that whether your model is safe or not. This you can directly see in the project 2. Whatever the plot you have, that is safe or not, that you can only validate by comparing each directional plot data. For example, if you see the conditions here in the animate deform results, I would like to see the deflection about y, and here you can see how the deflection is happening, and the animation may be anything, but we are interested on this technical data. By seeing the technical data, you can validate a problem. By seeing the animation, you cannot validate the problem. So animation is just for reference sake to see how the excitation is happening. And for doing more practice, you have couple of exercise as well, which you need to understand, which you can take any problem and you can apply it, and there is no restrictions that only whatever I am showing this you have to do. Any problem you can pick from the industrial course or from the CAD data or from your books or from any industrial component or cases, and you can execute the analysis because basic principle is same for all the cases. Thank you.